Hi everyone. Today we want to use Landsat 8 and 9 image for flood mapping. Landsat satellites provide a high resolution multispectral imagery and Landsat collection to Tier 1 Level 2 data. Used here is a atmospherically corrected surface reflectance data, and we use it the NDWI, and this is a widely used remote sensing index to detect the surface water, and it leverages the green and near infrared or NIR bands with a formula of NDWI equal green subtract near infrared divided green plus near infrared, and greens from the bond tree, and the water strongly reflect the green light in this bond, and in the near infrared bond 4, water absorbs the near light and appearing the darker in this bond. Thus higher NDW values more than zero point 0.2 typically indicate the water bodies, while lower values may represent land or vegetation. For flood detection using NDWI, floods are by comparing the NDWI values before and during the flood. Pre-flood NDWIs, we have a normal water extent, but during the flood, NDWI increased water extent, and areas with low pre-flood NDWI and high flood NDWI are likely the new flood. So we selected the Bangladesh for case studies areas, and to load the Bangladesh boundary from a FAO GIUL dataset and center the map for resolution. If we run this, we zoom at the Bangladesh and we set the pre-flood and after the flood. The data set represent the known monsoon flood period in Bangladesh. We have starts and end for pre-flood and flood period, and we load the process of Landsat 8 and 9 with this dataset for model investigation. For this dataset you can find on a Earth Engine data catalog available from 2013 until now, and we have a revisit interval 16 days. You can read there the descriptions, and you can see the bonds and the pixel size and unveil them. And after this, yeah, we return the code and we use it the cloud cover for the 50%, and we need to multiply some number from the user documentation, and we want to find the image from the time starts. And after this, we calculate the NDWI. We use the function get NDWI to calculate NDWI using the green bond 3 and near infrared bond 5, and create the median composite for uh, each period. Because this is take a median of all image in each period to reduce the flood noise, and we use this method, and after this we apply the NDWI with the function we defined above and generate NDWI image. With this line we detect the flood, flag as pixels that become water during the flood, mean NDWI increase it, and display the NDWI and detected floods like this. We define the mean and max value -1 to max 1 with the white blue for pre-flood, white blue for flood NDVI with the same range, and for the flooded area, detect the flooded area, we use it to update the masks and the palette of only the red. And optionally, you can add the display the two color image, or if you prefer, yeah, you can only use this. If we run the code, You can see we have a 3 layer. We can turn on and off. You can see we have a pre-flood NDWI, and this is the after one. You can see we have increased NDWI here, and if we turn on the layer of detected flood, you can see we have red color here and there's some red color flooded areas for here. Yeah, this method provides an effective and scalable way to detect the flood affected area using open source Landsat data and NDWI index, and it's ideal for rapid assessment and can support the disaster response planning and the rescue planning. And yeah, thank you for your watching, and please like and subscribe our channels.